A stone thrown upward with initial velocity of v naught equals 16 feet per second from an initial height of h naught equals 96 feet follows an equation for its height and feet as a function of time, y of t equals negative 16t squared plus v naught t plus h naught. Determine the parts A through F. So our position is a function of time, our height in feet is a function of time, y of t equals to negative 16t squared plus the v naught, which is a 16, times t plus the h naught, which is a 96. For part A, we want the velocity as a function of time. The velocity as a function of time is the derivative of the position as a function of time. The first term is a power roll. Bring down the power 2 times the coefficient. That'll give us a negative 32t. The second term is a constant times t. The derivative will be a constant. And the third term is a constant without a t. The derivative is a 0 for that. There's our velocity as a function of time, negative 32t plus 16. For part B, we want to know the time when the velocity is 0, so we can take that expression that we just came up with for the velocity as a function of time, set it equal to 0. Let's subtract 16 from both sides. And now let's divide by a negative 32. So we have negative 16 over negative 32, which comes out to a 1/2. So it looks like time equals 1/2. And time units are found in the initial velocity. It's seconds, so t equals 1/2 second. For part C, we want to know the maximum height reached. The maximum height occurs at the moment when the velocity becomes a 0, because the stone is changing over from having moved upward to now moving downward. It hits 0 briefly at that time. And we found the time when it hits the 0 at 1/2 second. That's where it's turning around from heading upward to now heading back downward. Our y max is therefore y evaluated at that time we found in part B, 1/2. So we have negative 16 times 1/2 squared plus 16 times 1/2 plus 96. So we have negative 16 times 1/2 squared. We can square the 1. That's a 1. We can square the 2. That's a 4. We have this plus 16 times 1/2, which is 16 over 2. And then plus 96. So we have a negative 16 times 1 over 4, which is negative 16 over 4. We have a plus 16 over 2, which is an 8, and then plus a 96. Negative 16 over 4 is a negative 4. Plus 8 plus 96 combined to be 104, and negative 4 plus 104 comes out to 100. Our units are in feet for position, we can see here, and therefore 100 feet as the maximum height reached. Part D, we want to know the time when it reaches the ground. The ground is defined as a height of 0, so we can take the height function of time, the y of t, and set it equal to 0. We can start by factoring a common factor of a negative 16, giving us a positive t squared, a minus t, and the 96 divided by a negative 16 will be a negative 6. We have a trinomial that can factor. So we have a t and a t. We need two numbers that multiply to be a negative 6 and add to be a negative 1. It sounds like negative 3 and positive 2 will take care of that. And we have this equal to 0, so that t is a 3 and a negative 2. Times can only be positive, though, so we can ignore the t equals negative 2, and the only time we have for reaching the ground is t equals to the positive 3 seconds. For part E, we want to know the velocity when it reaches the ground, and we just found the time when it reaches the ground. That can be plugged into the velocity function that we have in part A, v of 3. v of 3 will be negative 32 times 3 plus 16. Negative 32 times 3 is a negative 96 plus 16. And negative 96 plus 16 is a negative 80 in units of feet per second. The negative indicates that it's headed downward when it reaches the ground, which should be the case here. And then for part F, we want to find the acceleration as a function of time. The acceleration is the derivative of the velocity function of time, which itself is the derivative of the position, so therefore the acceleration is the second derivative of the position function of time. Now we have the velocity function of time in part A. We can take the derivative of this here. The first term is a constant times t. The derivative will be the constant, negative 32. The second term is a constant with no t. The derivative will be a 0. And the units of acceleration are distance or length units, feet, divided by the time units squared, so seconds squared. And we therefore come up with a negative 32 feet per second squared.